Hello everyone, my name is Tanvez Reddy and I'm from first year of engineering from CSE Cybersecurity studying in Sri Venkateswara Engineering of College. Now I'm going to explain about the topic corrosion. Let us know what is corrosion. So corrosion is a chemical process that deteriorates materials such as metal and occurs when metals react with their environment. Example, rusting of iron. Corrosion may occur either in a dry environment or in an aqueous medium. Let us know about dry corrosion. It is nothing but chemical corrosion. It involves the direct attack of metals by dry gases, mainly through chemical reactions. For example, the attack of dry air or oxygen on a metal to form an oxide layer over the surface. Next, let us talk about wet corrosion. It is also nothing but electrochemical corrosion. It involves reaction in aqueous medium. The conducting surface of the metal undergoes an electrochemical reaction with the moisture and oxygen present in moisture. Now, let us talk about the types of corrosion. First, uniform corrosion. This is the most common and basic form of corrosion. It occurs evenly over the entire surface of a metal, often caused by exposure to air, water, or other corrosive environments. And the second one is galvanic corrosion, also known as biometallic corrosion. It occurs when two different metals are in contact in the presence of an electrolyte such as salt water. One metal acts as an anode and another corrodes faster, while the other metal acts as cathode and corrodes more slowly. Third one, pitting corrosion. It is localized corrosion characterized by a formation of small pits or crates of the metal surface. It can be more destructive than a uniform corrosion because it creates deep holes. Next, let us talk about ceramic corrosion. Occurs in narrow gaps of ceramic between two surfaces. For example, the picture shown in the pipe. The limited access to fresh air and water in these spaces can lead to accelerated corrosion. Hydrogen embrittlement results from the absorption of hydrogen, leading to a reduction in the ductility and strength of the metal. Next, erosion corrosion results from the combined effect of corrosion and mechanical wear, often caused by the flow of a corrosive fluid or a metal surface. Now let us talk about the effects of corrosion. We have seen in our daily lives the effects of corrosion. Let us talk about the material degradation. It is the primary effect of a corrosion is the deterioration of the material itself. This can weaken the structural integrity of the material, leading to failure or reduced performance. For example, in the case of a metal corrosion, it can result in the loss of material thickness and strength. Reduced structural integrity. Corrosion can compromise the structural integrity of components, leading to the failure of structures such as bridges, pipelines, and buildings. This can have serious safety implications, especially in a critical infrastructures. Financial cost. Corrosion-related damage can incur sub- substantial economic costs. Industries and business may face expenses related to a repairing or replacing corroded equipment. Conducting mate- Conducting maintains and addressing the indirect cost of downtime and production loss. Environmental impact. Corrosion can result in the release of pollutants into the environment. For example, rust from corroded metal structures can contaminate soil and water, causing environmental hazards. Aesthetic degradation. Corrosion can have aesthetic consequences affecting the appearance of structures and objects. This is particularly relevant in industries such as automotive, architecture, and art preservation. Impact on infrastructure. Corrosion in infrastructure components such as bridges, pipelines, and water distribution systems can have a far-reaching consequences. It may result in service interruptions. Now let us talk about corrosion control methods. There are some corrosion control methods. We are going to talk about protective coatings, paints, and primers. Applying a layer of a paint and primers on a metal surface provides a barrier that shields the material from the moisture and corrosive elements. Galvanization. Coating metals, particularly steel, with a layer of zinc through a process known as galvanization. Zinc acts as a sacrificial anode, corroding before the base metal. Next, powder coating. A dry powder is applied to a metal surface and then heated to form a protective durable coating. This all comes under protective coating. Next, let us talk about cathodic protection. Galvanic cathodic protection involves connecting a more reactive metal to metal to be protected. The sacrificial anode corrodes, protecting the base metal. Immersed current cathodic protection uses an external power source to provide a continuous protective electric current to the metal, preventing corrosion. Corrosion inhibitors. Chemical inhibitors, these are compounds that can be added to the environment or applied directly to the metal surface to reduce the rate of corrosion. Inhibitors form a protective layer on the metal, hindering the corrosion process. Alloying. Incorporating corrosion-resistant alloys into the material composition can enhance the overall resistance to corrosion. For example, the addition of chromium to steel produces stainless steel. Now let us talk about some case studies in our daily life. Let us talk about the case study 1, that is corrosion in a coastal steel bridge. A steel bridge located in a coastal region has been in service for 20 years. The bridge is exposed to a marine environment characterized by salt water, high humidity, and strong winds. Over time, signs of corrosion, including rust formation and structural degradation, have become apparent. The factors that are contributing for this corrosion is saltwater exposure, high humidity, weathering, lack of protective coatings. Now let us talk about the case study 2 in our daily life, that is corrosion of vehicle bodies and chassis. A fleet of commercial vehicles used for transportation and logistics has been experiencing accelerated corrosion on their bodies and chassis. These vehicles operate in diverse environmental conditions, including exposure to road salts during winter and high humidity in coastal areas. The corrosion issue has become more pronounced, leading to concerns about the structural integrity of the vehicles and the performance impact on the engine components. The factors contributing to corrosion is road salt exposure, high humidity, limited protective coatings, etc. Now let us talk about and we'll conclude this topic of corrosion by saying that corrosion is a common problem with a significant economic and safety implications. Prevention and control techniques are essential for maintaining the integrity and longevity of the materials and structures. Corrosion is a persistent challenge that can significantly impact the integrity and performance of various materials, particularly metals, in diverse environments. It is a complex process influenced by factors such as environmental conditions, material composition, and operational parameters, and it is effectively managing and preventing corrosion requires a multifaceted approach that combines proactive measures and responsive strategies. In essence, corrosion control is an ongoing process that requires a combination of technical expertise and regular maintenance practices and a commitment advising the environmental changes. Now, thank you for watching this video. I hope you all enjoyed the video.